So I'm going to talk about maps in Power BI. So hopefully everybody's in the right place. Nobody's leaving, so that's good. Quick introduction then. So my name is James Dales, and I'm a director at Avanade, a global consultancy firm where I'm the Power BI lead. I'm also a Microsoft MVP and the co-leader of the London Power BI user group, where we're meeting actually here this evening at 6:15 in the room next door. So if you haven't had enough Power BI by the end of the day and fancy a bit more, then please do hang around for the user group as well. So I'm going to, as I said, talk about maps in Power BI. I'm going to have a look through the different options that we have in Power BI for creating different types of maps. And the good news is I'm going to do most of this through back-to-back demos. I've hardly got any PowerPoint slides whatsoever. Obviously, that's high risk, and there's lots that could go wrong, but keep your fingers crossed for me, and hopefully we'll get through the session with most of the demos working. So before we get into those demos, though, let's just very quickly remind ourselves what options we have in Power BI out of the box for creating maps. Well, we have 5 core visuals that come with Power BI Desktop: map, filled map, shape map, Azure maps, and ArcGIS maps. Now, those first 4 maps that I mentioned here are created by Microsoft. Very noisy next door. The 5th visual is created by a company called Azure, who are a specialist GIS company. Now, as we'll discover throughout the session, we can only go so far with the out-of-the-box visuals before we either hit feature limitations or performance limitations, and we have to fall back onto custom visuals. And there are many, many options available to us now that have been provided either by Microsoft partners or the Power BI community. And I'm going to put my hand up now and declare that I've created one of those, icon map. So we will feature some icon map in this presentation as well. And despite the fact I'm going to talk about custom visuals in Power BI, my advice always is, where possible, use the out-of-the-box visuals as much as you can. Firstly, they're supported by Microsoft, and they should, and I say should, perform faster, in that your report should load quicker, and then the visuals will render faster. However, with maps in Power BI, that's not always the case, and sometimes we do have to move over to custom visuals to achieve either the performance that we need or the level of complexity. So let's move out of PowerPoint and into Power BI Desktop and start creating some maps. And I'm going to start off by creating some point maps. So a point map is where we want to put a circle on the map to indicate something about particular specific locations on the map. And we're going to highlight those using a circle, which can either be a specific size or a specific color. And the data set that I'm going to use for that is hopefully relevant to where we all are today. I've downloaded from data.police.uk the last 12 months of crime data for London. So I was going to say fortunately, but perhaps that's not the right word. Unfortunately, that gives us quite a lot of data to play with and plot onto our map. So I'm going to start with using our first out-of-the-box option, the map visual. So let's add that onto our report. And let's just have a quick look down here on the right-hand side at the data we've got to play with. So in our London crime data, we've got one row representing each crime that has occurred over that 12 months. So we've got a crime count field. Every single value in this crime count field is number 1. So we can aggregate those up to tell us how many crimes have occurred either on a specific time or in a specific place. So in terms of places, we've got a few geographic fields. We've got the longitude and latitude. That represents the center point of the street where the crime occurred. But we've also got a lower super output area. That's a statistical code that kind of aggregates up a group of streets. And then at the top level, we've got the London Borough, the local authority area, which is our highest level in our geographic hierarchy. So let's start by configuring the map. So if I start by adding longitude and latitude, dragging those into the appropriate fields on the map, you'll see that straight away we get what looks like a good representation of our crime data on the map, in that we get lots of points scattered all over all of London. But there's something to really be wary of in doing this. We've got this little eye icon at the top right-hand corner. And that's telling us that there's too much data to be able to plot onto our map. So Power BI has had to take a representative sample of the data that we've provided it to plot. And let me just show you exactly what that means. So if I add on a card visual and take my crime count field, and let's do a, actually let's not do that. Let's use the point field and add that as a card value, because this will tell us exactly how many distinct locations we're trying to plot on the map. So we've actually got just under 60,000 distinct longitudes and latitudes that we're trying to plot on the map. Well, the limitation of the map visual in Power BI is 3,500 points. So we're trying to tell Power BI to plot 60,000 points, and it's saying, I can only actually do 3,500. And it's taking its best guess of which ones are important, but it's important to bear in mind Power BI is doing that, you're not. And if I drag on the crime count field, you'll see this even more. So if I drag crime count into size, have a look what happens to those points. Now suddenly we're seeing a very different 3,500 points, and we've got lots of gaps where there were crimes being shown before. So we have to be really careful when using the map visual that we're not missing out data. Now there are strategies that we can use to deal with this, and one of those is to aggregate up our data through that geographic hierarchy. So if I pull on the London boroughs, and before I can do that I need to change my longitudes and latitudes to be averages. And what that will do is it will take the average longitude and latitude within each London borough. So we essentially are plotting the center point of where all those crimes have occurred within each London borough. And now we're only plotting a handful of circles on the map, and our little warning indicator signal has gone away. And then what I'm going to do is I'm going to pull on our additional fields, so that next level down in the hierarchy, our LSOA code, and then all the way down to the point. So the point is the combination of our longitudes and latitudes in a single field. And now you'll see that we've got the drill down options available. So I can drill down into this larger circle, which is Westminster apparently. And we get a view there of crime in Westminster. You can see we've got a bit of an area down here, and perhaps this is the biggest circle here. I think I clicked on the wrong one there, didn't I? I meant to click on Westminster into that big one there. And we can see that we've actually got Oxford Street here with a particular hotspot for crime in Westminster in central London. So this is one strategy that we can adopt for dealing with those really large volumes of data, but using the out-of-the-box visuals. And we can change the colors to create a bit of a heat map effect, but I still have a bit of a fundamental issue with this sort of map. And circles are fine at the granular level when we're indicating really close details on the map, but when we're up at this high level, and I've got a circle here representing Westminster, and you can see I've managed to click on Camden by accident. It's really hard to see where the actual boundaries are of Westminster and Camden when we're just plotting a circle in the middle. A better type of map for plotting that kind of data is a choropleth map. So a choropleth map is where we're actually going to draw those London borough boundaries and then use different colors and shading to represent, in our case, the amount of crime in each of those areas. So let's have a look how we can create choropleth maps in Power BI. Now, the good news, if I go back to my crime data, is that we've got quite a few options. So the visual that Microsoft have provided for creating choropleth maps is the filled map. Now, the filled map, unfortunately, has a bit of an issue when it comes to working with a lot of geographies outside of the United States. So if I zoom in on London, it'll give you a bit of an indication. You can see that only some of our London boroughs have been shaded. We're lucky, to be frank, that it's managed to shade that many. If we were looking across the whole of the United Kingdom, we would only have a scattered number of local authorities that have been shaded. Is that a question? So it's hard to see.
Is it possible to import some of these areas from the local geographical?
Yes, so the question is it possible to import our own boundaries into this visual to be able to use our own local? I'll be there in just a moment. So the issue is that using the filled map is pre-configured with specific geographies, and if it doesn't know about them, there's no way of bringing your own into this particular visual. But we will look at different options for bringing our own geographies in a moment. So if we're sticking with out-of-the-box visuals, actually the best visual for representing our London crime data is actually the ArcGIS map. So I'm going to show you very quickly how to configure that. Now, when you add this map onto the visual, it asks you whether you've got an ArcGIS subscription, which I haven't. I'm going to stick with the free functionality. If you do have a subscription, then there is the option to bring in your own geographies. So let me pull on London boroughs and number of crimes into the color field. And you'll see that it starts plotting circles all over the world because London borough names are used in lots of different countries. I'm going to configure the map, though. I'm going to go in here and for our boroughs, and you'll see that configuring the ArcGIS map has its own bespoke user interface for doing this. Click on the three little dots here, go to location type, and say, instead of plotting points, I want to plot boundaries, and that they're in one country, not many countries. And then we have to say what sort of geography, need to choose United Kingdom in there. And then we have to say what sort of boundaries they represent. And we have a few choices here. We have districts, which our London borough boundaries are. And if I click OK, close that option down, hopefully we will get a map of London that for some reason I've managed not to colour in as a choropleth map. It should do in a moment. But you can see that we've managed to plot our London borough boundaries on the map. The problem is, though, as we had the question earlier, if we have a set of boundaries that ArcGIS map doesn't know about, then we're still stuck. We're not able to plot them on the map. ArcGIS map does support quite a few useful ones, and particularly statistical geographies and things like postcode areas. But if we're trying to plot data like maybe sales territories, that are completely arbitrary or bespoke to your own company, then we need the ability to import those from an external source. And Power BI does give us another visual that is capable of doing that, called the shape map. So I'm going to pull the shape map onto the report. Now, if you don't see shape map in your own Power BI, the reason is that it is still a preview feature. And it's been a preview feature in Power BI now for 6 years, I think. But I heard in an earlier session today that might change. So just to show you, if you go down to preview features, you'll see here at the top of the list we have shape map visual. Now, if you're using the February version of Power BI Desktop, as I am today, unfortunately, there's some bugs in this release of Power BI relating to this visual. So you need to make sure that you have the new format pane turned off. Otherwise, we won't be able to load in our own bespoke geography. So let's have a quick look how we configure this. I'm going to pull in London Borough, again into location. Turn the new format pane off and shape map will work fine. Save your report, turn format pane back on, and you'll be fine. it's fixed in the March release, which I think should be out soon. But it's just if you're using the February release that we've got this problem. So I pulled in borough into the location and crime count into color saturation. And you see we've got a map of the United States. That's fine. There are some inbuilt existing geographies, but they're all quite high level. For example, in the United Kingdom, we can only go down as far as countries, England, Scotland, and Wales. But what we can do is add our own bespoke map. And this is the option that's broken with the new format pane, incidentally, which is why we've turned it off. And what that lets me do is import our own boundaries in a format called topo.json. So if I choose London local authority boundaries, there we get our choropleth map. Now, topo.json's quite an unusual format. It's not probably the most common format used in the GIS world. So if you're downloading UK geographies from somewhere like the Office for National Statistics or Ordnance Survey, they're likely to come in formats like Esri shapefiles or GeoJSON files. Fortunately, there are a number of free tools that we can use to change from one format to another. And my particular favorite one, is an online tool called mapshaper.org. So it's just mapshaper.org. And then let me find a file. Literally drag my existing file in. There it is. What I recommend you do, if you're using these raw formats that you've downloaded, before you export it out, is to go to the Simplify option and then drag your slider down as far as possible, making sure that you've got just enough level of detail, because otherwise these files can be really big. They can be 30, 40, 50, or 100 meg sometimes, and you really don't want to be importing a 100 meg file into your Power BI desktop file because you've already increased its size by 100 meg, which it has to load and render before it can show that on the report. So if you find a suitable level of detail, export it out, save it as topo.json, then you can import it into the visual in the way that I did just now. Now this is quite a good solution, but there are a couple of limitations here that may or may not be an issue for you. The first limitation is probably the most obvious, and that's that we've now got no background map. We don't have street maps underneath here to show, right, here's Westminster, but actually, what are the roads that make up that boundary underneath Westminster? We can't put it into context with our real-life geography. The second limitation is that there's no ability to drill down into more detail on this map. I can't pull in my LSOA code underneath borough and zoom in further. That option's just not there. So what I'm going to show now is how we can create a choropleth map with a background layer and the ability to drill down into additional level of detail. But we can't do that with any of the out-of-the-box maps in Power BI. This is where we do start needing to fall back into custom visuals. And there may be multiple options for doing this. I'll say now I haven't gone through all the custom visuals. There have been some new ones released recently. I'm going to use icon map because I'm most familiar with it. So if you're not familiar with custom visuals, easiest way to get icon map is to go to click on the three little dots here, get more visuals, and you'll get the Microsoft App Source pop-up appear, hopefully. And if you filter by maps, you'll see all of the different options in here, and icon map appears here. Click that, and you'll get the icon appear down here in the custom visuals area of the visual selector. So we've added that onto the report. Let's configure it. So we're going to start with London boroughs again, drag that into the category field, and crime count into the size field. And you'll see that we get our background map straight away, which is based on OpenStreetMap layers. And now I want to add my custom boundaries. Now with icon map, these need to be hosted on an external web server. So In my case, I've hosted them up in Azure on some cheap website storage. You can also do it for very little cost using Azure blob storage as well. So let me grab. Oh, hand up, yeah.
Does that mean that if you change the file that you've hosted, then the boundaries can change without having to impact on the Power BI report and pull that in each time?
Yeah, that's true. Yep. So,
That's the problem we couldn't crack.
okay. Well, I'll come on to that specific problem. So the question was, if you host an external file and you then change the boundaries within that file, does then the report change to reflect those updated boundaries? And the answer would be yes. But actually, I'm going to show in a moment a different solution where you can have your boundaries changing over time, perhaps, or according to other factors in your data. So we'll get to that question in a moment.
Would you have to republish to get those changes to go off?
No, so you don't need to republish a report for those changes to come through, because that GeoJSON file is loaded each time that your report is rendered. So each time you flip to a page with that visual in, it will pull those GeoJSON files back down from the web server at that point. Well, let's have a look at how that works. So if I go to the formatting options of icon map, turn on GeoJSON, and paste in my URL, we'll see that we get our boundaries in the same way as we had with shape map. And I can go up here to formatting and use conditional formatting to apply those the colors. Let's base that on crime count. So the more crime will go from light blue through to yellow to dark blue. That'll do. And we can see here that Westminster is highlighted as that area with the most amount of crime. And actually, while I'm here, let me just show you one other useful feature of icon map. If I can scroll to it, I've zoomed my settings in, so hopefully you can read the formatting panes, but it does mean there's not a lot of space to show. One of the features that we can add on icon map is labels. So we can actually see what each of those local authority areas is without having to rely on the tooltip. But I'll turn those off for now. So we've got our London boroughs. One of the things I wanted to show you was how we now get down to the next level of detail. So I've got my LSOA code. Let's drag that in. And similarly, I've got an external file for the LSOAs as a GeoJSON file. So I go back to my formatting options, down to GeoJSON, just increase the number of levels to 2. We get a new text box appear here for level 2. Paste that in. And then I'm just going to refresh the report to force it to reload those GeoJSON files in. We've got the drill down options here. And hopefully if I drill down into Westminster, we now get those more detailed polygons appearing. And the reason we've got grey polygons and coloured polygons is the grey polygons relate to all of those other LSAs in boroughs that we're not currently viewing in our drill down data. But I can turn those off. We've got quite a lot of formatting options in here, one of which is to hide shapes with no values. So I can do that and turn it off. The only thing now, actually, looking at that, is it's quite confusing to see with that coloured map background. What I prefer to do when I'm creating a choropleth map is to choose a much paler map background. And one of my favourite ones is actually a map box layer. So I'm going to change my background layer to Mapbox. To use Mapbox layers, we need to use their Mapbox access token, which you can sign up for free on their website. Paste that in, and actually it's the Mapbox Lite layer that I like, and then we get a much cleaner view of that map. But I still have an issue with this. We're still forced to host those GeoJSON files on an external server of some kind, which is fine if you're dealing with public geographies like this. I mean, these are publicly available open data. But what if I'm working in an organization where my boundary data or my other shapes that I want to put on the map are sensitive? You know, perhaps I'm working in oil and gas and I want to map my gas pipelines, for example. We don't want those necessarily hosted on a public-facing web server. Well, one of the options we have with icon map is to host the actual boundary data or shape data within the Power BI data model using a format called well-known text. So let me just show you my second table of data in here, abbreviated to WKT, well-known text. And you can see here for each lower super output area, each LSOA, I've got the actual boundary of that, the polygon, represented in my Power BI data set. And the same for the local authority, the London Borough as well. So let's turn off GeoJSON. Where's that? And instead, I'm going to say that for each row of my data, that object relates to a local authority well-known text field, so that polygon data. And now we've got our exact same polygons rendering, but that data's come from inside our Power BI data model. No reliance on an external resource to be able to plot those boundaries. And if we want to go one level further and include that drill down functionality, I've just created a quick DAX measure in here to detect what level of the hierarchy we're in and return the appropriate well-known text field. So let me choose that WKT measure instead. And now we've got the ability to drill up and down that hierarchy with no dependence on external resources for that potentially sensitive data. Okay, so that's choropleth maps. There are other ways of achieving these, but we've only got 50 minutes, so I thought I would move on and have a look at different types of maps. So the next one we're going to look at is the ability to draw images and lines on maps. And to do that, we're going to stick with icon map, but switch to a different data set. So earlier in the pandemic, I used the FlightAware API to download every single aircraft that was currently in the sky at that particular point in time. And as it was quite early in the pandemic, I think in the middle of our first UK lockdown, there weren't actually that many planes flying at that time. So it's quite a nice concise data set to be able to plot on the map. So let's have a look at how we can do that. So icon map again. This time I've got aircraft in my data set, and I've got a unique ID for each plane, so drag that into category. I'm also going to use that to drag into the size field, which will just do a count, so every single plane has a number 1. That just means I can plot everything as the same size, because every value is the same. And then latitude to the latitude field, and longitude to the longitude field, and we get, as you probably expect on the Bing map, a circle representing every plane in the sky. But we don't want to see circles, we want to see planes, right? So similar to GeoJSON, I've got a picture of a plane hosted on my external website, and I've just created a DAX measure for simplicity to store that URL, so I don't have to remember it on the fly. So back to objects, where we previously selected the well-known text. This time, we're just going to select that plane measure with the URL of my plane. And they're very, very small, but they are all the same size. Let's make them a bit bigger. Now we've got a map full of planes. But they're all flying to the North Pole. That's not quite what we want either. Fortunately, in the data set, we've got the heading, so the compass bearing that that plane is pointing at that particular time. So what I can do in my format options is rotate our image around that number of degrees. So let's choose our heading field. Let's change that to average, just in case there's more than one row. And now our planes are pointing in the direction of travel. So that's quite nice. We can see where the planes are, but we can't really see yet where they've come from or where they're going to. But we do have the origin and destinations in here. So I'm going to drag in the longitude and latitude of the origin. I think we're on there, yep. Oh, they come through as counts. Let me change those to averages. And that's quite messy. Let's just create a slicer quickly and have a look at just a few flights at a time for now. So let's just pick the first couple of flights. Look like they're heading over from Europe to the US. Normally, when we show planes flying across a map, we expect those lines to follow the curvature of the Earth. So again, in my map formatting options, let's change those lines from straight to geodesic. That's not a bad start. We can see where the planes are coming from. That black line's a little bit bold, isn't it? I could change the color, but actually I can provide a custom dash array in there to give us some dotted lines. But what I think might help here is if we, instead of just drawing a line from the origin to where the plane is now, one of the things I was able to download with the FlightAware API was the actual waypoints, the flight plan that those planes were supposed to be flying on. And I've captured that again in well-known text. So similar to how we had the polygons before, instead I've got line strings, so longitude and latitude points along the path that plane should be flying. So I'm going to remove off our destination longitude and latitude and go back to objects where we chose our image, and instead of the image I'm going to choose a different measure. So so for these planes where I have the flight paths, I now have 2 rows in my data. I've got one data to draw the plane icon, one row to draw the plane icon, and the second row to draw the line, the flight path. So this measure just picks out either the image or the line string according to which row it is. And now you can see that I've got some much wigglier lines, if that's a word, with our planes over here to show where they are currently on that flight path. It's quite interesting, isn't it, how we've got this wiggly line as we go past the UK here. It does make me wonder what that is for. Perhaps there's some storm system over in the Atlantic that might be affecting things. So let's have a look at that. What I do have is a subscription to OpenWeatherMap that provide real-time weather background layers. So if I go in here and have a look at overlays, well, actually, let's add a daylight terminator. So that will show us where on the Earth is in daylight and darkness. That's quite nice. And actually, if I zoom in far enough, I can show you this feature. You can see this updates every second to show in almost real time where's light and where's day. But what might be more useful for us is to turn on a custom overlay and paste in my OpenWeatherMap URL. And now we can see that there is actually a bit of a storm system happening here over the Atlantic. So we've got our planes, current location, we've got the flight path plotted, we've got where's daylight and darkness, and we've got real-time weather all displaying on the map in Power BI. So that's images and lines. Before we move off images, just close that desktop file down, and I think finish with crime as well. Let's close that. One thing that I didn't show with the images, this is a little bit messy, but I built it quickly. On the last demo, every single image was the same. They were all the same plane. But actually, they don't have to be. Every single row can represent a different image. We just provide a different URL. So in this case, I've got all the coffee shops in London, or at least all the Starbucks, Pret's, Cafe Nero's, and Costa's. And in my data set, I've got 2 tables. I've got the locations, and then I've got a separate table for images. So 4 rows, one for each type of coffee shop. But I just wanted to point out in this scenario, instead of referring to an external URL, I've 64-bit encoded those images and stored them inside the Power BI dataset. So again, we don't have to be relying on external resources for things that might be sensitive in our organization. And in case anybody's getting peckish, shall we just quickly check? Here we are. There's the Excel Center. And it looks like, yeah, there's Starbucks on the bridge over from the DLR and a Costa just outside here, if anybody needs one. So that's images. What shall we have a look at next? Well, on most of these examples so far, I've only shown one type of map, or one type of object on the map at a time. But that's not a limitation. We can display different types of objects all at the same time. So I just built this as a little bit of an example of showing different object types here. So we've got a polygon, we've got a line, we've got a couple of circles, and we've got a couple of images that are rotated differently. And you can see here underneath, it's just a question of how we configure that data as to how it plots on the map. If we provide it with a polygon, it will draw a polygon. If we provide it with an image, it will draw an image. If we provide it with a longitude and latitude and no image or polygon, then it will draw a circle, and so on. So it's quite possible to have all those different types of images and have them all interactive and selectable on the map. Okay, so let's have a look at some more advanced features. Things that really, as a consultant, I have customers coming to me on a regular basis and saying, we want to be able to do this in Power BI. This is a key mapping feature that we can do in other tools. How can we do it in Power BI? Well, one of those things, I don't know if anybody here works for a public sector organisation, but in the UK, most public sector organisations have access to Ordnance Survey mapping for free. But the difficulty with Ordnance Survey mapping is it's based on a different map projection and different coordinate system to most other maps in Power BI. It uses British National Grid for its coordinate system, for example, which is 6-digit integers, not longitudes and latitudes. So let's have a look at how we can work with Ordnance Survey mapping and different sets of coordinates in Power BI. Now, I'm going to demo OS maps, but actually this relates to all sorts of different regions. Every country has its local mapping provider and a different coordinate system. So whilst I'm using a UK scenario here, this applies to other parts of the world as well. I'm going to use a different data set. I'm going to come back in and focus on London, and I've loaded in some more open data, but this time I've got every single property sale in London last year. Again, it's quite a large data set, and it's nice and granular. We've got data all the way down to postcode level that I'm going to try and plot. So let's go back and add on the icon map visual. And we're going to start with a geographic hierarchy again, because even though icon map can display 30,000 points on the map at any one time, we've still got way more data than that. Even with 30,000 points on the map, it's not enough to plot every property in London that was sold last year. So we're going to start off with London boroughs again. But we're going to go all the way down to postcode this time. So drag in borough, low super output areas again. Postcode, we still need our latitude and longitude to start with, just so I can show you what we're dealing with. And I'm going to pull in the price into the size field, and I'm going to change that to average. There we are. I've obviously done something I wasn't intending to, because we've got some random points up here, but let's not stress about that. So I've got a circle for each London borough. Let's drill down. let's go somewhere different. Let's go to Sutton, go to suburbia, where we might have a bit more of a range of house prices. And I'm going to drill all the way down to postcodes for every lower super output area. Let's format our circles quickly. Let's make them a bit smaller. Let's go down to, oops, not bigger, smaller. So we can see the variation in property prices. So we've got more expensive houses down here, and we've got cheaper houses up here. In fact, ouch! So £2 million for that particular sale there. All the way down, let's have a look at the other end of the scale. This one here, 150,000, a bit more affordable. It was probably a garage. Anyway, so what we're looking at here is still OpenStreetMap data. We haven't attempted to do Ordnance Survey yet. Let's do that. So again, I've got my subscription to Ordnance Survey maps, and what I need to do is go and select it in background layers, but before I do that, I need to tell the map visual that we're going to change to British National Grid coordinates. So choose that in the coordinate reference system drop-down. Background layers, I'm going to provide a custom URI. Maximum zoom level for Ordnance Survey maps is 9, I think. Paste the URL in here. And now we have our Ordnance Survey maps that, if you're from the UK, you'll be very familiar with. Actually, while we're here, let's just format our circles to stand out a little bit better now. We've got those. Let's go bright red. There we are. So what I'm doing here is plotting longitude and latitude coordinates on top of our Ordnance Survey maps. My longitudes and latitudes are being converted to British National Grid and plotted on the map. But what if I've only got British National Grid coordinates instead of longitudes and latitudes? So just to show you what they look like. So here's latitude and longitude. Here are our British National Grid northings and eastings, so 6-digit integers. Well, all I need to do is swap over my longitudes and latitudes and pull in my northings and eastings. And then back here in the coordinate reference system, there's a reproject option. So I just turn that on, and it will convert my coordinates into longitudes and latitudes for me and put them back on the map. Do wonder what's driving some of these variations in house price. I know one of the things when you buy a house in the UK is you send off for all these surveys and they come back and check whether you're in a floodplain or not, don't they? Should we check that? So this is an example of where you've got an external GIS system in the organization where you want to pull in additional context information onto your map. So I'm hosting all of the UK flood data in GeoServer, but it could be Esri, it could be Map Server, or it could even be Mapbox. And I'm exposing these in one of the popular open source formats called WMS. So I'm going to turn on my WMS layer, paste in the URL, and say that it's my flood data I want to show. And now I can zoom in, and we've got those blue areas superimposed on top of my Ordnance Survey map. The flood data is also coming out in that 27700 projection that Ordnance Survey uses. And I've got my British National Grid coordinates plotted on top of that. So, one final demo. So I've shown what we can do with British National Grid coordinates on the map, different coordinate systems. What if we really want to go different with different coordinate systems? What if we just want to plot on a flat piece of paper XY coordinates? So our map might not even be a real geographic map. What if we've got, I don't know, got a theme park map, or perhaps a UK railway map? So here we have icon map again, but now we've got a train map. And let me just refresh this to kick off everything again. Hopefully don't crash on me. Here we go. So railway map, which is a flat image background picture. On top of that, we've got images, little icons of trains plotted on there. And if we go down here and have a look at this train, which I think is probably running a little bit late on schedule, we can now use the labels with conditional formatting red on the background to show that that train is running late. It's caught up a bit, it's only amber now, to pull up context information on there. And icon map doesn't do any animation at all. Hidden behind my map here, I've got the play axis custom visual, which is just looping through my time dimension, showing different different images on the map at that particular point in time. So we can really get creative with our maps and show all sorts of different things that don't even need to relate to real geographies. We've got customers doing things like zooming into microscopic samples and things like that, where they can use the lasso tool to highlight particular cells and things like that on microscope slides. So there's all sorts of different possibilities for things that you can do with this visual. Okay, do we have any questions?
One question was, is GeoJSON faster than WKT or the other way around? Which is faster?
That's a really good question. So the advantage of using I'll repeat the question if we can't hear. So the question was, is WKT faster than GeoJSON? They're different. I don't know that one's necessarily faster, but the advantage of using WKT over GeoJSON is you don't need to pull the whole file in at a time. You only need to pull in, or you only need to display those particular polygons that you need to see at any one time, rather than having to show every single shape, even if you can't see it on the map.
First question was, any advice on creating WKT data for the choropleth maps?
Yes. So if you want to create, so the question is, do you want, is there any advice on how you can create WKT data for choropleth maps? There is an open source tool freely available to download. It's a fat client, it's not a web tool. It's called QGIS. And that will allow you to load in data of almost any geographic format you can think of and export it as a CSV file. And one of the options is to include your geometry, your geography data as well-known text using that tool. Yep, the tool name is QGIS. Okay, I'll, for sake of a recording, if I search for it quickly. There you go. QGIS.org is the website. Any more questions online or in the room? I'll go to the online one first and then come to you after. Yep.
So I found one more question.
Yep.
Is there any support for route maps, thinking gritting routes, commuting options, etc.?
So is there any support for route maps? Thinking things like gritting routes, etc. So there's a couple of options there. One is well-known text. So we showed, I haven't got it on the screen, but we showed using line strings to represent those flight paths. You can quite happily pull line strings in representing those routes. Or if you don't need to interact with them and click on them, then if you can host those externally, I know I've got some icon map demos. Let me bring the slide up with the website. Oh, by the way, please leave feedback. We have a, if you go to icon-map.com, there's lots of different examples on there, and one of those is pulling in resources like route maps from third-party providers that show things like bus routes and gritting routes and tram stops. You'll find an example on the website doing exactly that. Okay, I believe we are out of time, but I'm happy to hang around here as long as I can and also outside the room to answer any more questions.
Thank you.
Thank you very much.